We are continuing on with another example in 5.2 Day 1 notes. So this time in these problems, we're given the sine of an angle alpha and the sine of an angle beta, and we are looking to find the cosine of alpha plus beta. So where I have the cosine of the sum of two angles, that's a clue to me that I'm going to have to use my formula above. Okay, so I know that the cosine of alpha plus beta is equal to, again, I'm just copying above, the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. Okay, and so again, I'm just copying that right from my equation, from my formulas above. Very important that I copy it correctly. So I am given sine alpha and I am given sine beta, but I don't have my cosine alpha and my cosine beta values. So what I'm going to do is I'm going to draw these angles, alpha and beta, in standard form, and I'm going to determine the cosine from those drawings. So I'm going to draw my coordinate plane, and I see that my alpha is between pi over 2 and pi. So I know pi over 2 is here, pi is here, so that means my alpha falls somewhere in the second quadrant. Okay, and it's also important that we are always measuring our angles from the x-axis. So I'm going to call alpha this angle right here. And I'm going to draw in my right triangle. So this tells me that my sine of alpha is 4 over 5. And I know that my sine is equal to my opposite over my hypotenuse. So if this is my angle alpha, my opposite is going to be 4. My hypotenuse is going to be 5. So I recognize this as a 3, 4, 5 triangle. I also notice that my x is going in the negative direction, so I need to put in a negative 3. Similarly, I'm going to draw in my angle for beta. So I know that it tells me that beta is between pi and 3 pi over 2. So here is pi, and here's 3 pi over 2. So my beta is going to fall in my third quadrant. Okay, so again, I'm drawing in my beta. I'm always measuring from my x-axis to my terminal side. I draw in my triangle. Again, my sine is opposite over hypotenuse. So my opposite is going to be 2, and my hypotenuse is going to be square root of 5. This 2 is going to take on the negative since I'm moving in a down direction. So now I need to find my adjacent side. I know that this is also my x value. So I have that x squared plus negative 2 squared is equal to my hypotenuse, which is the square root of 5 squared. Okay, that's just using the Pythagorean theorem. So I have x squared plus 4 equals 5, squaring each of the terms. So I have x squared equals 1 when I subtract 4 from both sides. So x is equal to plus or minus 1. So looking at this, I notice that I'm going in the left direction, so that means my x is negative 1. So now I can figure out my cosine of alpha and my cosine of beta. So my cosine of alpha is going to be my adjacent over my hypotenuse, which is going to be equal to my adjacent is negative 3 over my hypotenuse of 5. And my cosine of beta is also going to be adjacent over hypotenuse for this triangle, which is negative 1 over square root of 5. Okay, I can also write that as negative square root of 5 over 5 if I rationalize the denominator. And now it just becomes plug and chug. I need to stay organized. I need to make sure that I'm looking at the correct angle, but I'm looking for the cosine of alpha which is negative 3/5, times the cosine of beta, and the cosine of beta is negative square root of 5 over 5, minus the sine of alpha is given in the problem as 4 over 5, and the sine of beta, also given in the problem, is negative 2 square roots of 5 over 5. So simplifying this, I get negative times negative makes positive, so 3 square roots of 5 over 25. Negative times negative makes a positive, plus 8 square roots of 5 over 25. I have a common denominator, so and I have like radicals, so I can simplify this as 11 square roots of 5 over 25. And this would be my final answer. So our next one, we want to find sine alpha plus beta. So again, I just need to look above and see that my formula is sine alpha cosine beta plus cosine alpha sine beta. Okay, and this is just a matter of substitution. So sine of alpha is 4/5. Cosine of beta is negative square root of 5 over 5. Cosine of alpha is negative 3/5. And sine of beta is negative 2 square roots of 5 over 5. Okay, so again, simplifying, I get negative 4 square roots of 5 over 25. I'm just multiplying the first term. Negative times negative makes positive 6 square roots of 5 over 25. Combining over the like denominator of 25. Minus 4 square roots of 5 plus 6 square roots of 5 gives me 2 square roots of 5. And again, this would be my final answer. In my last problem, tangent of alpha minus beta. So I can see that this is, from my formulas above, tangent of alpha minus tangent of beta over 1 plus tangent of alpha tangent times tangent of beta. Okay, so looking above, I don't have my tangents yet, but I can find them easily. So the tangent of alpha is going to be the opposite over the adjacent. So my opposite is 4, my adjacent is negative 3. And similarly, my tangent of beta. So again, my tangent of beta is my opposite over adjacent, which in this case is negative 2 over negative 1, or 2. So again, substituting in from above, my tangent of alpha is negative 4/3, minus my tangent of beta is 2, over 1 plus my tangent of alpha is negative 4/3. My tangent of beta is 2. So simplifying real quick, this is negative 4 minus 6 over 3, right? I rewrote 2 in terms of thirds, and this becomes 3 minus 8 over 3. So this becomes negative 10 over negative 5, which is 2. Okay, as always, if you have any questions, please come for extra help.